Welcome to our module on farm-focused composting. Here we'll explore how composting practices can enhance soil health and productivity on your farm. We will investigate different techniques and benefits of composting from a farmer's perspective. Initially, let's examine the cage method, which can be utilized by small-scale farmers. This requires construction of a robust frame using wire mesh or fencing material. Let's investigate the various kinds of materials utilized. When it comes to composting, materials are typically classified into browns, greens, and manure. Browns are carbon-rich materials like dried leaves, tree branches, rice straw, and wood chips. They provide structure to the compost pile, create air pockets for oxygen circulation, and absorb excess moisture. Including enough browns in your compost mix is essential to maintain the proper carbon to nitrogen ratio, typically around 25 to 1 to 30 to 1. Greens are nitrogen-rich materials such as corn stalks, grass clippings, and green sunflowers. These materials supply vital nutrients for the microorganisms responsible for breaking down organic matter in the compost pile. Greens also activate the composting process and accelerate decomposition. Manure from herbivorous animals like cows, horses, or chickens is a valuable addition to compost. Rich in nitrogen, manure introduces beneficial microbes to the compost pile, which speeds up decomposition. However, it's important to use manure from healthy animals and allow it to age before adding it to your compost pile to prevent potential pathogens or weed seeds. Materials are shredded and chopped mechanically into smaller pieces. This increases the surface area and facilitates decomposition. Now we will delve into the process of mixing the ingredients. To begin, add a layer of brown materials such as dried leaves, tree branches, and rice straw. These materials, rich in carbon, give the compost pile structure and absorb excess moisture. Next, layer green materials on top of the brown layer, including corn stalks and grass clippings. These nitrogen-rich materials provide essential nutrients and kickstart the composting process. Then, introduce the manure layer to the compost mix. Continue the process by alternating layers of brown, green materials, and manure. Turn and mix the mixture regularly to incorporate the layers together, adding water as necessary to maintain moisture levels. Strive for a balanced ratio of approximately 3 parts brown to 1 part green materials by volume. The composting materials need to be dampened with dechlorinated water, which is sprinkled over the layers to moisten them evenly. The overall moisture content of the compost pile should be 60 to 65% akin to a wrung-out sponge, but not overly saturated. You can verify this by squeezing a handful of the mixture. If a few drops of water are visible between your fingers, it's adequately moistened. Ensuring the right moisture levels is crucial for promoting microbial activity and efficient decomposition. Water serves as a thermal buffer, helping regulate temperature changes and fostering an ideal environment for microbial processes to thrive. Aeration is vital in composting because it ensures that the microbes responsible for breaking down organic material receive the oxygen they need to work effectively. This is achieved by regularly turning the compost pile, allowing air to reach all parts of it. Turning involves splitting the pile into sections and mixing the layers together, bringing the lower layers to the top. This introduces oxygen and ensures even distribution of moisture and nutrients. It's important to aerate the compost pile regularly, ideally every 1 to 2 weeks, to promote efficient decomposition and prevent anaerobic conditions. Temperature is crucial in composting because it accelerates the breakdown of organic material by microbes. As the compost pile heats up, microbes work more efficiently, speeding up decomposition and transforming organic waste into nutrient-rich compost. Higher temperatures also help eliminate weed seeds and pathogens, making the compost safer and more effective. Temperature in compost making is typically measured using a compost thermometer. Insert the probe of the compost thermometer into the center of the pile, ensuring it reaches a depth of several inches. Leave the thermometer in place for a few minutes. Then observe the temperature displayed. In composting, there are several stages in the maturation process. Initial stage, fresh organic materials are added to the compost pile. Microbes start breaking down the materials, releasing heat and beginning the composting process. Active decomposition, microbial activity increases, raising the compost pile's temperature to 45 to 65 degrees Celsius. Curing stage, the compost pile cools down as microbial activity slows. This stage allows the compost to mature and stabilize, with beneficial microbes continuing their work at a slower pace. Maturation in the final stage, the compost is fully matured, 2 to 3 months, having a dark, crumbly texture and earthy smell. It's rich in nutrients and beneficial microorganisms, making it ideal for soil amendment in gardens, lawns, and landscaping. The compost material produced through the composting process is a nutrient-rich, organic matter that resembles dark, crumbly soil. This compost material is teeming with beneficial microorganisms and contains essential nutrients like nitrogen, phosphorus, and potassium, making it an excellent soil amendment for enriching garden beds, nourishing plants, and improving soil structure.